Good morning, everyone. Welcome to this other session of the OpenShift Coffee Break here at OpenShift TV with this show about everything about OpenShift and the cloud native architecture. My name is Natale Vinto. I'm product marketing manager for OpenShift, and I'm here with my colleague and mate, Jaafar. Hey, Jaafar, how are you?
Hey, good morning, everyone. It's great to be back here and have some coffee, although I forgot to take one this morning. So let's let's see how it goes.
Go remediate immediately, because today we
Yeah,
have a
exactly.
very hot topic, which is the open cluster management. And I'm very pleased to welcome our guest today, which is Gianni Salinetti, solution architect at Red Hat. Hey, Gianni.
Good morning. Good morning, Natale, Jaafar. Nice to meet you. Happy to be here. So today we're gonna talk about open cluster management, its admission and CNCF. Yeah, very nice topic.
I'm really looking forward to it, Gianni, because I'm very interested in knowing what is really this open cluster management, how it's related to Kubernetes, multi-cloud, multi-cluster management. I know it's a hot topic in the market. Everyone has its own solution. We also have in Red Hat OpenShift our solution, which is ACM. So Gianni, correct me if I'm wrong. This is the upstream. Those are the upstream bits of advanced cluster management for Kubernetes.
Yeah, that's correct. OCM, or Open Cluster Management, it's the upstream for Red Hat Advanced Cluster Management for Kubernetes, and it's totally open source. So one important thing is that Red Hat acquired the solution some time ago and open sourced, and everything was open sourced, following the usual behavior of Red Hat in these cases. So when Red Hat gets acquires so a product, maybe a proprietary software, and it becomes something that is managed by Red Hat, it's open sourced. Maybe it takes some times, maybe it can take 2 months, 1 year. It's up to how it's written, but finally it's open sourced. And OCM, Open Cluster Management, is an open source, completely usable version of the multi-cluster management solution of Red Hat, and it's the upstream that drives all the changes to ICM. And the very nice thing, is that it's being currently admitted as a sandbox project to the CNCF. So that's something we can discuss later, because it's very interesting, because it's a very important signal to me. It means that this is something that it's really ready for the community.
Yeah, that's great. That's great. And yeah, correct me also if I'm wrong, but what I find interesting with this specific product from the ACM standpoint and project from the community standpoint is that we all know that Red Hat has been acquired by IBM some time ago, and maybe some people started freaking out. Is Red Hat going to remain committed to open source, and are they going to hold on to these core values and things like that? And if we can also tell the backstory, the product itself comes from IBM engineering. In the beginning, it was called MCM, Multi-Cluster Management for Kubernetes, actually. And after the acquisition, the engineering was transferred from IBM to Red Hat, and not like the other way around, from Red Hat to IBM. So I think that was a very cool proof of both IBM's and Red Hat's dedication to committing to open source. And now we see the outcome of it, which is we have the Red Hat product, which is Red Hat ACM, and we created the upstream and the community for it with open cluster management. So I think it's really satisfying to see that Red Hat stands to these values and see that we are still, pushing things in the upstream.
Yeah.
So
absolutely agree.
Yeah. And I can't wait to see you showcasing the product.
That in action. Yeah, it's a
Yeah,
really
we're
nice
gonna
story.
see something in action right now. First, I wanna point out something that's very important. Sometimes the project can be open source, but maybe the upstream cannot be fully usable. So maybe you have a project, maybe you have many repositories on GitHub, but it's hard to people to assemble stuff, make it work together. So the main thing it's that open cluster management is something that works out of the box. So it's a distribution that works for everybody on every kind of Kubernetes cluster. It can be installed. We now showcase on a basic vanilla cluster on Kind. So very basic thing, not on OpenShift. It works everywhere. And it's something that works out of the box. It's very important to me because you obviously have your repositories. You can investigate the code. You can contribute to the code, very important, but you have something usable.
Yeah, you don't have to rebuild the whole thing yourself and be like a black belt engineer to have something ready. You have the binaries there and you have the container images and it just works. So that's great. In terms of
it just works.
Making it easy to adopt and use.
Yeah, and I like what you say, Jaafar, that the story is the Red Hat way, to do the things, an acquisition, then the open sourcing of a product, and now we see the results. So I would like to share in the chat the website of the result, which is the website of the Open Cluster Management. So if you go to this website, you will see all the details of the project, all the GitHub repository, and how to join this community, which is the very important part of the overall process. And I also would like to ask Gianni, before we go into, I know of course we have a live demo, right? Of course we have demos, and where Gianni will show us how it works in local Kubernetes and how to make it working with multi-cluster. But before going that, Gianni, what does it mean that a project is accepted as a CNCF Sandbox project? What does it mean for the community?
It's very important because it means that the cloud native the CNCF, the Cloud Native Community Foundation is ready to include that project in all their ecosystem. So it's included in their ecosystem map. They have many degrees of acceptance. So you have sandboxed, you have graduated, and mature projects. So you start from the sandbox and then you graduate. So it means that the CNCF is looking at this project, is helping it grow. And it's a huge up, it's a huge boost, because when something goes inside the CNCF sandbox, it gains a very important visibility and boost. So it means that we have something that is going to grow. It's going to grow quickly, probably, because we have something that it's ready to be used. It's ready to be adopted by different kind of Kubernetes users. Obviously, it works great in OpenShift because, we are talking about OpenShift after all here. So, but we have something that it's native for Kubernetes. So it just works using custom resources. So you can apply that everywhere. So the point is, a sandboxed project is something that is really helped in growth. That's my opinion about the importance of being graduated to the CNCF.
Yeah, but I also think that it means that there's acceptance from a broader set of users and contributors than, like, I would say, the traditional Red Hat fellows, because CNCF is a broad scope of, it's a very large ecosystem, right? And being sandboxed there, that means that there are people that adhere to like the the tool and the features that it can provide, and that this can be useful for Kubernetes as a community and as an ecosystem, and not just like an end software vendor solely, which is Red Hat. So that's also, you know, this notion of being accepted, and that it serves a broader purpose for Kubernetes community itself.
Yeah, I fully agree. It's something that is accepted somehow by the community. As
We hear your microphone a little bit far. I don't know if
something has changed, I think.
Mine too?
Yeah, in yours. Or
no, I am probably some volume setting. We hear your keyboard, and we know that you are prepping super cool stuff to show us, but we also see you less.
Maybe now it's better.
Yeah. Yes.
All right. Thanks. All right. Maybe I can try to show something, Natale. What do you think?
Yes. Before you go, I would like to ask the people attending. So there's a Tigerfly that say that the microphone was not good, but I think now Gianni solved it. I hear a little bit of echo, slight echo, but I think it's fine. So now the microphone is fine. I would like to ask to the people attending, if you have any question about open cluster management or everything, please write in the chat. We will bring the question to the speakers during the live.
So I do have a question, if I may.
Sure.
So what is this? Actually, what is it, and what is the purpose of this tool? Like, if you can very briefly introduce the purpose of it, its main functionalities. I'd say even before going into the demonstration.
Yeah, absolutely. Right. The point is, managing multiple cluster is complex. You know, when you have to deal with many clusters, it's complex to manage resources, keep them aligned and synced. So multi-cluster management is a topic that is a long story. It's something that has been discussed since the beginning of Kubernetes. And there were many solutions. There were many attempts to manage this. The concept is you need a single pane of glass to manage all your clusters. You need a single point when you can apply your changes, where you can monitor the state of your clusters, when you can monitor the deployment of your applications, and also maybe when you can manage in a declarative way your infrastructure. Declarative way, that's a very important point. You need to, for example, to manage your application lifecycle in this way. So maybe using a GitOps approach, using a Git repository when you have your application's configurations. So all this stuff together. And also maybe you need to manage policies for your clusters. Also, in a declarative way, you need to integrate policies as soon as you join your clusters to your multi-cluster infrastructure. So all these things together can be solved by a unique solution, which is Open Cluster Management. With Open Cluster Management, you essentially have one manager. It's called Hub Cluster usually. It's responsible to manage a series of clusters. It's responsible to apply a series of custom resources to your managed clusters. And you can do it in many ways. We're going to see how. And it's responsible to monitor the state of your clusters, which is very important because you can see the health of your clusters since you have agents running on your managed clusters, which continuously report the status of your cluster. And using those agents, you can apply changes to those clusters. You can make groups of clusters. For example, you can manage cluster sets and apply in bulk changes to a single set. And you can do a lot of things. And one very important is application lifecycle management. Maybe if you have some time later, we can try to also to apply an add-on, the application lifecycle add-on, and see how you also can do GitOps with Open Cluster Management. You can just declare your application configuration on Git repo and do it and apply changes on managed clusters. So all this scenario makes the use case, the basic use case of Open Cluster Management. And to do this on OCM, you have two main components. A cluster manager running on your hub cluster. So you need a central hub cluster to control all the others, just like the Lord of the Rings, one ring to rule them all. You have one hub cluster to rule them all. And you have managed clusters, which run those agents called clusterlets. The clusterlet, think of it like a kubelet in a Kubernetes worker node. The clusterlet is the agent, it's an operator, which communicates with the hub, reports the status of the cluster, its health, its metadata, and also gets from the hub cluster information about the changes that must be applied to the managed cluster. So you have a work agent in there, in a managed cluster, that continuously enforces, it reconciles, using a Kubernetes related term, the changes on a managed cluster. So it's a matter of reconciliation, you know. It's just a matter of reconciling resources in a declarative way. So you are just doing the same on the managed clusters. That's the main concept of OCM. Also, if you want to, for people who try to understand it better, if you go to the OCM documentation, which is on a link that Natale shared, you also have nice graphs, architectural graphs about the design of OCM. This is the basic design. Then, on top of it, you can add many add-ons. For example, the application lifecycle management, which is an add-on. You can add the policy manager, which is another add-on who lets you deploy policies on your clusters. So it's some kind of configuration management. For example, you maybe want to apply default configurations. Maybe you want to create some config maps on your clusters as soon as they join your cluster set. So it's great for that purpose. For example, in ACM, so in OpenShift downstream related, I use these policies to deploy operators. As soon as I join a cluster to ACM, I apply a policy that deploys one or many operators on my cluster. So without using any other tool, I just need to join the cluster. As soon as I join the cluster and I apply some labels to that cluster that match my policies, it gets all the configuration immediately. And that's great, because in this way, sorry, but go please.
Yeah, so I was going to say, so some examples that maybe people can more easily understand is, say you have new clusters that you created, 15 new clusters, and you want them all to integrate to your LDAP or your central authentication system, so your users can have access without needing to push the configuration to each one of them. That's something that you can enforce, like say, okay, whenever we create a new cluster, just configure yourself to authenticate with our central authority or whatever tool we use, and that's one step that makes it easier for you and your users. And maybe something else like central logs. You want all your clusters to push back logs to your central logging system. Okay, just push a policy there, and whenever you have a new cluster, it's going to configure itself to send back the logs to whatever meaningful log system needs. It needs. So yeah, that's some types of like standard policies that you could push. Of course, there are also some functional policies like I don't know, things like PCI or stuff like that, where you can enforce some specific types of policies.
If you recall, Jaafar, we had the demo from Faz and Andres in one of the previous show. They did a great demo about ACM. Now, Gianni, I would like to say this. Show me the code, dude. So please, nice words. Now show us the code. Show us the evidence.
Show us the money.
Let's start with our deployment. So I did this short deployment on purpose, similar to the documentation. So if you look at the documentation, there's a quick start, which is very nice, and it's based on kind. So you don't need, oh, wow, big Kubernetes clusters. No, you just need kind. What is kind? Kind is a tool for deploying Kubernetes in Docker. It's the name kind. So it's an acronym for Kubernetes in Docker. So kind lets you create very small Kubernetes cluster inside a container. We are not going to use Docker for this. Kind also supports Podman, which is our container engine. It's great. It's a great tool. It's daemon-less. It's great to use. It works in the rootless mode. I use it in rootless mode for this demo, for example. So you don't need nothing but running Podman. It's amazing. And so we run two kind clusters, one hub and one managed cluster, and then we deploy open cluster management on top. It's very easy. It's something that everybody can reproduce immediately right now. So let's share this video. Can you see it?
Yep.
Yes.
Yeah, let's start it. So now you see I have two tabs here. I did one tab for the hub and one tab for the managed cluster. The managed cluster, it's going to be created right now. Now I'm creating the kind hub, the kind cluster, naming hub. So kind is creating the cluster. Now I'm creating the cluster one, the managed. See that kind says that I'm using the Podman provider here, not Docker. So it takes very little, just a minute to bootstrap two clusters.
One question, if to enable the Podman provider, did you provide any environment variable, how to switch from a Docker to a Podman provider?
No, it just
recognize
the provider, right?
Oh, okay, cool.
So now my cluster is started. So I just need to monitor if the containers are completely started. Let's see. I pass the context to use the specific Kubernetes context here. Kind hub is the name of the cluster. So you see, it's very fast. It's very small. It's minimal cluster. Everybody can run it on their laptops. It's very easy. And it's great to experiment with Kubernetes. It's a great way to do your first steps if you are starting to learn Kubernetes, and also to make some quick experiments. Okay, everything is started on a hub. I just want now to deploy stuff. It should have, okay, cluster ADM. What's this? It's the CLI tool that deploys the open cluster management. I pre-installed this CLI, obviously. So just one command, cluster ADM init. It initializes my cluster, my hub, and creates this message. This is the command with the token I should run on the managed clusters to join them. Now, before joining the cluster, let's see if the deployment of OCM has completed. So you see it's still creating the containers. It has created two namespaces, Open Cluster Management and Open Cluster Management Hub, which contain the cluster manager and also the other add-ons. As soon as it's finished, we can move to the managed cluster. So you see, it's very easy. I just created the hub cluster, nothing more. Just one command.
That's
So
super
yeah,
cool.
this might be obvious, but all the components are actually containerized, right?
Yeah,
So it's a sort of microservices based architecture for OCM and ACM, and all of them run into containerized
yeah, absolutely.
into containers.
Absolutely. So now I copy the join command and run it on top of the manage cluster. So I just pass the cluster name and the context. So I want to run this on top of the manage cluster because I need to say to the manage cluster, hey, join the hub. And this is the token to join the hub. Very easy.
That's cool. So you basically have two Kubernetes nodes created by kind in your workstation. So anyone in Linux, Mac, Windows can install kind and reproduce the same demo. And you are joining those two clusters with the one is the control plane, and one is the let's say data plane or controlled cluster.
The manage,
node.
yeah,
The
absolutely.
The managed cluster.
Yeah. That's cool. So we have two nodes. One is controlling the other, and just one
Two
command,
clusters, right?
two clusters,
Just two comments.
Yeah.
two different clusters, and just one command to join one cluster to the manager one.
Yeah, absolutely easy. And the the team of OCM did a great job with the CLI. So you have now just a message to finally accept the cluster. The managed cluster now made a request to the hub. Hey, please join me. So you have you can see that you have custom resources on a hub. You have this very important custom resource, the managed clusters. You can see that you have a pending managed cluster. You see, hub accepted false. It's not already accepted. The hub must accept it. It's just a matter of accepting a CSR. Here it is. We have this pending CSR. So by running the cluster ADM accept command, we implicitly, under the hood, we are accepting a CSR. We don't need to know this stuff, indeed. I'm just showing it to make it more complete. But you see, I just run cluster ADM accept, and the cluster is joined. So everything now is, please, Jaafar.
Yeah, this is interesting because the managed cluster had nothing, had no relationship with the other cluster beforehand. So it wasn't created by something else. It's just like a regular Kubernetes cluster. Once you execute that command, it deploys like the clusterlets and whatever it needs, and then it reports back to the hub cluster. Is that correct?
Yeah, correct. Exactly.
So basically, you import any Kubernetes cluster as a managed cluster in there.
Absolutely, any kind of Kubernetes cluster. So now we can move to the. Let's stop this and let's move to a live shell, so live terminal. Can you see my terminal?
Yep.
Okay, so I want to show you something more inside the clusters. This is the hub. So you see now inside the hub, we have this those containers here that are related to the cluster manager. And if I move to the managed cluster and I run oc get pods -a -context kind cluster one, I pass the context of the managed cluster. We can also use, I'm using OC, I can use kubectl here, obviously. Yeah, you see, we have the two namespaces, Open Cluster Management and Open Cluster Management Agent, and we have this pod deployed. What's this? The clusterlet is the agent that communicates with the console plane, with the cluster manager on the hub. And the clusterlet also deploys some extra agents. In this case, the registration agent, which is the the purpose of registering the cluster and the work agent, which role is to apply the changes that you declarative define on the hub. So every change you do on the hub, every resource you create on the hub is applied by the clusterlet and its work agent on the managed clusters. So the point is, you don't have to touch your managed clusters anymore. You can do anything from the hub right now. If you have 1, 10, or 1,000 of managed clusters, it's just the same. What do you think about this?
I think this is great. So one question that one might ask is there a big overhead on the managed cluster? Like, does these agents weigh a lot in terms of CPU RAM, or is it something negligible?
Oh, well, this configuration here is quite lightweight, and it's very basic. So the components we are running here are not using a huge amount of resources. What changes is the API pressure as you grow your managed cluster number. So as you grow number of clusters you join to the hub, you obviously increment the number of API calls between the cluster manager and the clusterlet. So this is something that as an input on the API pressure. What's the concept of API pressure? We can define it as the saturation of the API calls on your cluster. So your hub has a limit of API pressure that it can stand according to the sizing on your hub. So when you design the size of your hub, you must be aware of the number of your managed clusters.
Yeah, so that's why the hub is running on a dedicated cluster, I guess. So it can scale up to managing thousands of clusters. And I believe on the ACM part, we did some tests up to 2,000 managed clusters or something like that, which is quite a lot.
Absolutely. So the point is, as much as you plan to grow your infrastructure, you have to somehow adapt the sizing of your hub cluster. Obviously, when we deal with a small number of managed clusters, here you have just one. It's really small resource usage.
So here everything runs on your laptop. Is that right?
Yeah, my laptop alongside with another Kubernetes cluster running on virtual machine, my Chrome browser with 40 tabs opened, one application for playing music, Ardor, which is a DAW software for Linux. So I think that my laptop is managing it very well.
Very nice. So pretty lightweight from what we can see.
Yeah, so pretty lightweight.
I have a service communication. Unfortunately, we cannot stream at full HD at the moment. So from YouTube, you would see 480 because I think there's a wrong setting in the streaming machine we are using. We will correct in the next show, but for now, I'm sorry we can have full HD. I hope you can see everything enough good. So Gianni, to help this, maybe you can increase the font as the max you can, because the people cannot have full HD. So thanks, and sorry for this problem.
No, don't worry. Can you see this font size? Is it readable? Please tell us.
Yes, I think it's easier to read now. Cool.
Should be fine.
Okay.
All right.
So show us the magic. What else can we do?
Yeah. First, you created a managed cluster. So on your hub, you have a resource That's it. That is a managed cluster resource, and you see the name of your managed cluster, cluster 1. So you treat it as a custom resource. So you can do it something like this.
So just for people who maybe are not that familiar with Kubernetes, basically a custom resource is an extension of Kubernetes API to add your own concepts that become a native resources of Kubernetes. So now Kubernetes understands the notion of what a managed cluster is because we extended the API through the OCM installation.
Thank you, Jaafar. I missed this. It was a very important point. Thank you.
Yeah, sure.
So you see, this is the custom resource of your managed clusters, and you can create metadata on this managed cluster. You can apply labels, for example, and you can use labels to apply configurations on clusters that match a specific label. I also did a repository. I can share it in chat with some extra examples taken from this session. I share it on chat. There it is. And here we can see, for example, how to apply a specific resource, a manifest work, on top of the cluster. What is a manifest work? It's a custom resource, as Jaafar just explained, that says to OCM, create this object on specific clusters. So to create a manifest work, it's very easy. I just need to apply a resource in a namespace named after the managed cluster. So if I look at my OCM here and kind hub, I can see that it has created a namespace with the name of the managed cluster. Very easy. If I create something inside here, this object will be applied to the managed cluster. Very easy. So I can move to my repository. If I move to cluster management directory, manifest work, I have this file, hello work. It's just a very basic deployment. You see, very, very easy. It creates a deployment object inside a cluster. So what happens when I create this object? When I create this object inside the namespace cluster 1, the managed cluster, the clusterlet, applies using the work agent this object to the managed cluster. And I just do it declaratively inside one directory in the hub. I don't touch the managed cluster. Any questions about this? Is it clear?
Gianni, just one question. You told that you shared in the chat something, but we haven't seen anything. Where did you share it?
Sorry, looks like I shared it. Yeah, looks like. Let me share you on chat on Telegram. Sorry, Natale.
Yeah,
you can do it. Yeah, I shared you.
Okay, thanks.
On Telegram or on our internal chat?
In the Telegram coffee break chat. I will put it now in the chat. So examples repo. Okay, now we should have all in YouTube and Twitch. Please let me know if you can see it. So the people can look at the examples, Gianni, and can run the same example you're doing right now.
Yeah, absolutely.
Okay. Cool.
They can be applied on the managed clusters as I'm doing. So if I create this resource here, I just created this resource inside a namespace named after the managed cluster, cluster one. So what I expect to see now is, here it is. Hello. You see, I'm on the managed cluster here, and it just created the resource immediately on the managed cluster. Quite simple. And this is something that can be applied to any kind of resource. I just created a deployment, but I can do anything, just like Jaafar said before. And it's very basic approach. We can make more. We can evolve this approach. For example, using application lifecycle management. Just in that way, we can enable a GitOps approach. So we need to deploy some more add-ons. You find those add-ons in the documentation of the Open Cluster Management. So if you look at the docs, you see that in architecture add-ons, you see the additional how add-on work first. So you see how the add-on manager, you deploy an add-on manager on a hub. The add-on manager manages all the additional components you deploy, and you deploy agents on the managed clusters that communicate with add-ons. So if I want to, for example, to add the application lifecycle management, I just need to create these components on the hub and managed clusters that are able to sense changes to a repository. So you can use Git repos, but you also can monitor and charts or object stores, not only Git repositories. And using this approach, you can apply changes of an application to the managed clusters and do it everything in a declarative way. The nice approach here is that you start creating your application using GitOps approach by applying labels to your clusters. So you don't need anymore to know, for example, the exact name of the managed cluster where you want to apply your resource. You just say, I want my application on all the clusters with the label environment lab, environment prod. So every cluster with that label automatically gets the application because you just declaratively created a placement rule. That's the name of the approach. You define a rule that says how to place your application on your clusters. So in the repo, I did an example, a small example about application lifecycle management of a very simple Nginx application. It's very basic. So first, I'm going to show you how to install the add-on, and then we try to deploy the application in a managed cluster and see what happens. So
okay.
First step.
Yeah, sorry. So just maybe to touch upon something that is very important is when you come to that scale where we are managing tens or hundreds of clusters and thus thousands of applications, one of the questions that rise is how do you control what happens where? Like in case there's a problem, there's an issue, you need to troubleshoot. How do you figure out what happened, when, what configuration was pushed to what cluster? And if you do it like through command lines, I mean, that's totally something that you can do. You do a kubectl apply to 10 namespaces, and it goes there. It's going to be deployed from the hub to your 10 clusters. That's fine. But when you want to audit, like what version of the deployment was deployed and when, etc., it becomes a bit harder. And I believe that's where the GitOps approach becomes very handy, is because you have a traceability of what was applied when to which clusters, etc. So yeah, I think combining the two is really a great fit, because you have of course, the powerhouse of the hub and the clusterlets to deploy stuff, and you have the single place of truth, which is you push your one change to your Git repo, and then everybody else gets it, but you know when and why, etc. Or at least when, not necessarily why if there are no comments, but
Yeah, I totally agree, Jafar, because the hard part is when you manage not 2, 4, 5, but hundreds of clusters, and you need to keep control of everything.
Mhm.
Keep everything under your control and know what's failing where and why.
And you said there's a reconciliation, is that correct? Also, like if I go to one of the target clusters and tamper with something, is it going to be remediated with
Yeah,
this
exactly.
GitOps
Exactly.
approach?
Exactly.
Okay, cool.
That's a very important point. If you apply a configuration, so let's say I want to deploy an application to my clusters. Let's say I want to deploy this basic Nginx application. And let's say that somebody changes my deployment on the cluster using the CLI. It goes there and scales out, for example, my application using CLI, so interacting directly with the managed cluster. Agents in managed cluster reconcile immediately the application to the desired state. And that's one key point of GitOps, reconciling constantly the desired state of an application inside the Git repo with the current state in the cluster. So every change that is done in the cluster without this approach, by bypassing this approach, is immediately reconciled. Every change you do in your clusters must go through the Git repository. That's great.
Yeah, so yeah, very nice. And of course, very useful in real life when you have to manage up to that scale, as we said. Cool.
My 2 cents, many people love GitOps approach because also you can also keep control of changes. You keep track, of changes. You see every single you can see every single commit. You can approve your commits because you can create
pull requests.
Yeah, so you
Cool.
really keep control.
Gianni,
Very
you
nice.
are mentioning GitOps, but I'm wondering if GitOps means connecting to an existing GitOps engine like Argo CD or any other like that, or is there any other GitOps implementation there?
OCM has a native GitOps implementation with the application lifecycle management, but the great thing is that you can integrate it with other tools like Argo CD. And that's exactly what we do with ACM, Advanced Cluster Management, where you have a native UI that integrates with Argo CD resources. So you can see live what you create on top on your Argo CDs. So in that way, you can kind of separate your infrastructure resources you want to create, for example, with ACM, with your application resources you manage directly on the cluster with Argo CD. If we have some time, maybe I can show you an example of my lab where I run Argo CD resources integrated with ACM. But yes, the answer is yes. You have native GitOps approach, and you can integrate with Argo CD or other tools, and so get the best of everything.
That's super cool. It's agnostic, basically. You can plug in as an interface, right? So that makes really powerful.
So I had one question, but I think you wanted to show something before I mentioned the GitOps thing. I don't remember what it was. You were going
I wanted to show you exactly the application lifecycle management, which is the step 0 of the GitOps approach here, because we just deploy those components, deploy those agents, and then try to deploy in a declarative way using GitOps approach a simple application. And then we can extend the concept with Argo CD and more stuff. But let's start with the basics. So now I can show you that I just create on my manage cluster a simple command. With a simple command, I just want to I install an add-on. The name of the add-on is Application Manager, and I used to do it with Cluster ADM, the CLI of OCM, the great CLI of OCM. So just run this command. So it's installing stuff. We can monitor what's happening. Let's get, you see, it's deploying more components. It's deploying some operators, these ones. And these components are basically 4. So you have a channel, a component that manages channels. A channel is let me say, a pointer to a repository. So it points to a specific Git repository that works with our application. Then you have placement rules. That's the rules that match your managed clusters. So placement rules can manage conditions, for example, the existence of a label, and subscription, which connect together placement rules and channels and say, okay, this channel pointed here, which is a Git repository, must be handled for these clusters here, managed by the placement rule. So in this way, you connect together the source of information, so the Git repository pointed by the channel, with the target, which are the clusters managed by the placement rule. So it's very easy. And we have deployed our components. So we need to make a last step. We need to deploy the agent on the managed clusters. So to do this, we run just a second command. We enable the add-on on the managed cluster. So I want to enable this on cluster 1. I'm running, I'm running everything from the hub. I'm not going to the managed cluster. I just enable the add-on on the managed cluster. So on the managed cluster now as an agent, as another container, another pod, which is going to be deployed on a managed cluster, which senses the changes that we do on the application lifecycle management on the hub. So we extended in a very simple way our hub with a new add-on, the application lifecycle management. Very easy, very, very plain, and just commands, just command to enable the add-on and just another command to enable the add-on on the managed cluster. Stop. We can do this with other add-ons, for example, policies. I think we don't have time to show policies too, but that's fine. So I just want now to run the application. So if I move to my repository, I have an example of an Nginx application. I have resources that should be managed inside my cluster. So you see, I have objects. I have a namespace that is expected to be created on the managed clusters. I have the channel, which is a pointer to my Git repository containing my application resources. I have a placement rule, which says, this is the most important thing, which is saying apply these changes, apply these resources on all the clusters with a label env lab. It's just label. I just create this label on a managed cluster and see this applied. I can apply this label to 1,000 of clusters and have the application deployed to 1,000 of clusters just with one command. And then I have a subscription. Subscription connects together everything. So it subscribes to my repository and applies the changes to the cluster matched by the placement rule. And inside the resources directory, I have the files I want to deploy inside the cluster, the resources, just a deployment and a service. Very easy. It's a deployment of an Nginx application, basic thing. and a service. And everything is declared inside my Git repository. So now I just want to create these things, but I'm missing something. I need to label my clusters. So I saw that my label was managed by the placement rule. I need to apply a label called envelope. So I just need to edit my cluster.
And this is all live demo, folks. All live demos.
All live, yeah. I just go here. Context, sorry, typo. And you see I have labels. I just add a very simple label here, env lab, just like my placement rule. So now, if I apply these resources in here, let's see what happens. Okay, apply the chef dot. I just apply the whole directory. Okay, I have created those resources inside my hub cluster, and let's see what happens on the managed.
I see a container creating.
Yeah, here it is. Nginx app. You see the namespace. It's been created. I have my deployment created, and I also have the service. That's the pod, and that's the service. Everything was created immediately. And if I change something on my Git repo, let's say I scale out my deployment, this is immediately reconciled to the managed clusters. That's great. And that's exactly how it works in advanced cluster management for Kubernetes. The main difference is that there, I also have a very easy, a very user-friendly UI to do everything, not only the custom resources, but if I want, I just can use the command line and the CLI, just like I did here.
That's cool. And so the core is open. The core is all upstream. Then, of course, the product has some UI, some things easy to install and maintain. And that is the supported, but the core is open source. The same bits are the one that letting you right now deploying Nginx to clusters. The same would be in ACM because the core is open.
Absolutely. And since it's open, my message is contribute, not just use, contribute to the community, because this is a great project that can grow even more in many ways, in my opinion. And so the contribution to the community, it's very important.
That's a great statement. I'm gonna put in the chat contribute, and there's the link in the website of Open Cluster Management about contribute, how to contribute, how to join the community on GitHub, on the working group, on discussion about this new community. I'm really looking forward to see that community growing more and more in the Kubernetes and cloud native space.
And just keep in mind that contribution is not necessarily by pushing code. You can also contribute to things like maybe documentation or samples. We saw that you just used some samples that you have on your repo, and if people start to build interesting things like that and then share those on the public repos, that can be great also, to help all of us use those resources and such things. So usually when people here contribute to open source, they think, okay, I have to be a black belt developer or something like that, but it can be different things. Contribution is also like filing bugs. If you find bugs, you file an issue on GitHub and you contribute to make it better.
I think that a great starting point in contribution is helping improve documentation, for example. You don't need to be a black belt developer to contribute to documentation, and you do great, huge work for everybody. If you create awesome documentation of a product, you you are enabling that product to the masses, because great documentation of a project is, my opinion, is the key of the success of that project.
I
So
agree. And
Totally
I,
agree.
I like what Jaafar and Gianni said. So start contributing, no matter how, documentation, bug fixes, or code. Please just discussions, as we said. Please just start contributing, join the community. That's a great wrap up and final for our show. That it's at the end. Unfortunately, we are at the end of our show. So I would like to thank everyone that joined it also in the chat. And Renato joined late, but Renato, you have the same, if you use the same link, the recording will be available as soon as we close the stream. So use just the same link and you can see the awesome demo from Gianni. Gianni, thank you very much for joining us. That was really great.
thank you, thank you so much for hosting me. It's been a pleasure. It's been very funny, and thank you.
Yeah, we look forward to have you in the next episode. Jaafar, some appointment for OpenShift TV today.
Yeah.
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 Please.
So, yeah, thanks a lot, Johnny, for the great demos. It was awesome. Everything worked. It was very well explained. So thank you very much. Yeah. So we still have some other shows coming up today, of course. If I may mention that I'm going to be doing one this afternoon on pipelines as code, which is a very nice upcoming feature on OpenShift, which is basically how to allow you to push your Tekton pipelines from the Git application. And that's another step towards GitOps, right? So GitOps, we used to push like the resources and stuff like that. Now we can also push pipelines, and then OpenShift figures out how to create the pipelines within the cluster. So it's going to be today at 3 p.m. And I'm going to put the link.
Yeah, I put the link in the chat of the streaming calendar. So you can join that link and see all the episodes of today. But if you have a direct link to the show, please share in the chat so the people can join.
Yeah. Okay. Yeah. So I just shared it, I believe, on YouTube, but I'm not on the stream chat. But if you, Natale, if you can get the link from our Zoom chat and paste it through Restream, that would be also helpful.
Yes, sure. Let me copy from our chat so we can share here. So this is the link to the OpenShift TV show, which will be on pipelines as a code, right?
Exactly. Yeah. So this is not exactly OpenShift pipelines like the Tekton downstream. It's a new feature that allows you to define your Tekton pipeline in your Git repository, and as soon as you commit your app changes, OpenShift triggers the pipelines automatically on OpenShift pipelines. It's similar to what we used to do with Jenkins file, where you have a Jenkins file in the repo, but it's more advanced because you can now react with pull requests and stuff like that. So stay tuned. This afternoon, I'm going to be doing a demo. So I hope, it's an interesting topic.
Can't miss it. It's, of course, it's another live demo here at OpenShift TV. So I would like to close up and wrap up everything. Thank you, everyone, for joining. The recording will be at the same link. I saw while Gianni were playing some Telegram chat from our OKD group. If you would like to join our OKD channel, which is the OpenShift community group on Telegram, please join by this link I'm putting here in the chat. And also, if you like to follow Gianni on Twitter, his Twitter handle, you feel free to follow him and say something about this awesome demo today. Jaafar, appointment today, OpenShift TV. The OpenShift TV Coffee Break will come back on December the 15th. We will have another app dev topic. with Alex Groom and other folks joining us. So please stay tuned and see you on December the 15th, same time here at OpenShift TV. Thank you everyone for joining, and see you next time. Ciao.
Thank you very much. Thank you, Gianni. Bye-bye.
Bye-bye. Thank you.